In this first problem, we're looking at times and they've been put in order for us. The mean time was 103.45 and it has a standard deviation of 4.61. Now, if you'll notice, 108.06 is exactly one standard deviation above, and that's key to this problem. So 108.06 is one standard deviation above the mean, which means it has a z-score of 1. Now, when we use the empirical rule here, we want to figure out what percent of times will be less than this. Well, below 0, which is the mean, is 50% of times. Between 0 and 1 is 34%, and we get that from breaking down 68.5. So we'd add on 34 to 50, and we'd get 84. Make sure to reference the picture and practice up to know these numbers pretty quickly. But 84% is below a z-score of 1. 16% would be above it. Now we have to look at the actual data, because this is theoretical according to the empirical rule if the normal model is appropriate, what we should expect. What are the actual percent of times less than 108.06? Going here to where it would be, we see 5 times are above it. 1, 2, 3, 4, 5, because it would be right in here. We have 53 total times, so let's go here and take 48 divided by 53. That's because if there are 5 times above, there would be 48 times below. So this is the actual 90.6. There is actually 90.6% of the observations below. Now, there's only 2 answers to this. If the normal model is appropriate, then they would match up pretty well. If the normal model is not appropriate, then they would not match up pretty well. Because the normal model is not appropriate, we're not seeing the empirical rule work out to be what it should be. Now, I've never liked this question, and I think the answer remains consistent. These 2 numbers look to be a little bit off, and I would like more data. I'd like to understand this better. But at this current time, I will say no, because the normal model is not appropriate. And I think that answer remains consistent throughout multiple problems. And this next question I love, because you can look at this data right away and tell you're doing the wrong thing. Because this data is not normal. It's something we talk about often, and we don't cover nearly enough on these quizzes, that when you are doing these chapters, you need to make sure you're doing it on normally distributed data. And there's 3 ways to test that. Look at the histogram, normal probability plot, and the goodness of fit test. So make sure to know those. Look at the histogram, normal probability plot needs to be straight, and the goodness of fit test should have a p-value above 0.05. Below 0.05, it's not normal. Review those concepts. According to the normal model, what percentage of receivers would you expect to gain fewer yards than 2 standard deviations below the mean? So fewer than 2 standard deviations. We do our 68, 95. That puts us to -2, +2. Now, outside of 95 is 5%. So below would be 2.5 and above would be 2.5. So we're only concerned about this below. So this is a check on the empirical rule right here. And the answer is 2.5. From these data, what does this mean? Now, just think about this for a moment. If the mean is 482, and we're going to do some estimations here. Let's round that to 500. Round that to 500 for the moment. And the standard deviation will round to 400. Now, 2 standard deviations would be 800. And that would put us at -300 if we go 2 standard deviations below. What do we see down here that kind of fits that mold? Some receivers would gain less than -252 yards. And that's impossible. You get kicked out of the league way before that. So it doesn't seem like this is a good idea. Explain why the normal model for this data is wrong. And right here we see that the data is heavily skewed to the right. Such a strong skew. We can't use it. Once again, we would want to probably give this a goodness of fit test, which it would fail. It would have a very low p-value. If we showed the normal probability plot for it, the normal probability plot for it would be very bent. And just look at the histogram. It doesn't look normal to me. This is a bad idea to use the normal right there. Now, these problems, they're kind of fun. We can use the David Emmaline applet to solve them pretty quickly. To get to the David Emmaline applet, go ahead and Google David Emmaline applet, and you'll see it right here. Now, the really great thing about these problems is they actually go in order, going from above, below, between to outside. Let's see if we can recreate these graphics for this problem. For this first one, we're looking for the area above a z-score of 1.8. So it wants a z-score greater than 1.8. 1.8 would be on the right side, and we want the area above. Now, I love doing the estimations on these because a z-score is standardized. So I know these because I've worked these problems a lot. I also know some numbers like 1.96 and 1.6445. Now you know the number 1 over here. Above 1 is what percent of the data? See if you know it right now. Above 1 is 16% of the data. 68, outside 32, and above would be 16%. Lots of practice. Above 2 is 2.5. So this answer here has to be between 2.5 and 16%. So good practice right there. It's probably going to be closer to about 2.5, and we could take a guess, and I love guessing. I'm going to take, for a guess, and this is just a guess that I like to do, I'm going to guess 4.4 at the moment. Let's see how close we were. The David Emmaline applet is going to allow us to get an exact answer. It's what we use these days instead of a z-table. And the exact answer is 3.59. And you see we were close because above 2 is 2.5% and above 1 is 16, and that's from the empirical rule. So we were pretty close. We didn't get it exactly right. We got kind of close. So let's put it in here to 2 decimals. I would have got this one wrong. 3.59. And that works with our reality. On the next one, we're going to do below. Below 1.05. In this one, we want 1.05, and we're going to go below, and that looks correct right here, below 1.05. Now, we can get a pretty good guess on this, because just wait for it. You got it. Because look right here. We're basically at 1. With that in mind, below 1 is how much of the data? And we did this earlier on the first problem. Below 1 is 84% of the data, and we're just barely above it. So let's see. I'm going to say 85.4. So let's type it in here. I'm feeling it's going to be a little bit more than that. I should have went a little bit higher. Below, and you want your graphic to match. And the answer is 85.3. Did I get it? Oh, will it accept it? It didn't. I need 2 decimals. So close. Because I knew it had to be very close to 84 because below 1 is 84% of the data, and I added on more. This number should be between 84 and 97.5. Using the empirical rule, we can figure that out, but it's going to be very close to 84, and we get it correct there. My first one was the guess, and I wanted to see if it would accept it, if I was close enough. Okay, for this next one, we want to go between negative 1.2 to 1.7. And sometimes you have to zoom in on these because these areas might be shaded. So it's best to zoom in if you're a little bit confused, zoom in and see what it looks like. We want to go between, so this will be the graphic here. Between negative 1.2 to 1.7. And this is going to be a much harder one to estimate because in reality, between negative 1 and 1 is 68. And between negative 2 and 2 is 95. So we're somewhere in between there. Maybe, and this is a really hard one to guess, it has to be between 68 and 95. So I'm going to take a quicker guess here. I'm going to say 82%. And let's see how we do. Negative 1.2 to 1.7, 84.04. And the whole guessing thing, I just do for fun. You don't have to do it. It's just to see like, oh, we're really close. Like, look how, this applet is great. But if you know the empirical rule, you can, get really close just by guessing. And the empirical rule helps you figure out what it should be. And this last one right here is perfect. It's one of the best ones to end on for us. And I'm so happy we got it. Because it says greater z, the absolute value of z is greater than 2. So what if the absolute value of z, we take 5? That'd be greater than 2. How about negative 5? Become 5 and it would be greater than 2. So it's these tails we're looking at right here. It is the tails we're looking at. And I hate to tell you this, and you might know this, but we say between negative 2 and 2 is 95. So you would tell me outside of that is 5. And you're close. But if I put 5 in there, I'll be wrong. Turns out between negative 2 and positive 2 is 95.449% of the data. So we can go on our calculator right here, and I'll show it. If we take 1 and then do minus 0.95449, because that is the truth for the empirical rule, 4.55, and that is the truth. because the 68, 95, 99.7 we told you about is a rounding of it. And you'll see that right here. Let's look at that real quick. Because I'm going to go outside of, and you'll see here, -2 to +2, and there's the answer I obtained. When we go to the between, you can see the exact numbers. So this is your first empirical rule. 68 is actually 68.27. We rounded it to 68 for you. 95, as I mentioned, is 95.449. It even rounds it there a little bit. Decimals just keep carrying out. 99.7 is virtually identical, but it's 99.73. So little extra decimals, get a little more. You don't need to know the extra decimals, but it's why you don't get exactly 5% outside. But still, remember, and we use this a lot, 68, 95, 99.7, but you can get the exact numbers from the applets, and that's why we love them. Okay, last problem here. So based on the normal model of a mean of 1,152 with a standard deviation of 87, describing steer weights, what are the cutoff values for the highest 10%, the lowest 20%, and the middle 40%? Now there is a button on this applet that lets us do all this. We just have to hit this second button right here to change it to percentages. So we need a mean of, and I need to look at it again, 1,152 and 87. And 87. Okay, so we need the highest 10%, I believe was the first one. Let's take a look. The highest 10%. Highest 10% and lowest 20. So the highest 10% is going to be somewhere in between here, because this is the highest 16 and this is the highest 2.5. And I can find it a lot of ways. I can put in 10% right here. And I can also realize that the highest 10% is the 90th percentile and do this. Lots of ways to display it, and you should become familiar with how we can display things here, because it might look different on the test. This could show the highest 10% because it's showing the lowest 90, or as we'd call it, the 90th percentile. So the answer is 1264 rounding up. So I think this asks for whole numbers. There it is, 1263.5. And then the lowest 20%, lots of ways to display this. I'm going to do this in a weird way. The lowest 20% could be displayed by showing this. And you have to watch out, be like, what exactly is this displaying? So if we have 60% in the middle, that leaves 40% on the outside, right? And that would be 20% down here and the 20% down here. That's actually the answer to the lowest 20%. And you'll see that if I do it an easier way of displaying it by going to 20 and doing that. So those answers are identical right there. Just lots of ways to display the same numbers. If you put 60 in the middle, you get 40 on the outside, which would put 20 on the low side and 20 on the high side, and it gives you both those numbers. So 1078.8. 1078.8. And last but not least, the middle 40%, which we can easily do. Going back to here, the middle 40%, just put in 60%. What? And do the outside. And then there's the middle 40%. If 60% is being shaded on the outside, 40% is being shaded on the inside. Once again, there are lots of ways to use this applet to get the same answers. I can make it display the way we would normally think of it, and there's the answers. And I believe this asks for, no, it's another question that asks for what the IQR is. This wants us to actually input those numbers, are blank and blank pounds. So let's see here. And it wants it to one decimal. Always check what it wants. 1106.4. And last but not least, our last answer is 1197.6. 11976. And that's got it. Good luck.